Okay, so I think we can start already. For the people who are joining just now, please feel free to go to ahaslice.com/Jarvis or scan the QR code on the screen to join our interactive warm-up session. We're going to start with just a few questions that you guys can participate in to answer, so that we also get to know you a bit better and we know who is the audience of this talk. But I would like to start by welcoming you all to this Jarvis conference, Space Edition. Let me go to the next slide. So this is the first ever Jarvis conference that we're organizing. And this year it's going to be held online, but we hope next year to be able to organize it actually in person in Lisbon. So we hope to see you all there as well if this is a success. So in this online edition, we're going to have 4 sessions every Thursday in June and July. And we will hear in these sessions from some of the most experienced and groundbreaking engineers in the industry who will share their best practices with all of us. And this is actually the second session of this conference. Last week we had with us John Benak from Nanoracks in a very interesting talk. And this week I'm very, very happy to have with us Sam Avery from Momentous, who is going to present to you guys. So if we look at the agenda for today, basically we're going to start with a 15-minute warm-up session, which is going to be interactive, which we've already started. If you want to go and join the warm-up session and answer the questions, you can go to this link in the top of the slides, ahaslice.com/Jarvis. And then after the warm-up session, we're going to have a 30-minute talk by Sam. And then we're going to end the session with the Q&A session, where you can basically ask Sam any questions that you have about the talk and about his work. So before we start with the interactive part, I would like to tell you a bit about who we are. So we are Valley Space. If you haven't heard about us, we are developing a smart collaboration platform for engineers. And we're organizing this Jarvis conference because we want to empower engineers, so empower you guys, and we want to bring this community together so that we can learn from each other and so that we can build amazing things all together. And I would just like to take this moment also to give a shout out and big thank you to Maria, who is my colleague at Valley Space, who's been working very hard to pull this all together. So thank you a lot, Maria, for organizing this. So without further ado, let's jump into our interactive session. If you still want to join, you can go ahead and join on this link here on the top. So let's learn a bit about you guys. My first question to you guys is, which country are you joining from today? Germany, Sweden, Portugal, Canada, UK. A bit of a mix, it seems, mostly Europe, but a few also from America. Singapore. Nice, we have a very diverse crew here today. Nice to see. London, Belgium. Nice. So now we know a bit more about where you're from. So let's jump to the next question. My next question is, which work background do you have? So what do you work as currently? Okay, a lot of system engineers, a few students, project manager, project engineer. Okay, and a few others as well. Okay, so I think it seems like we have mostly systems engineers and students. Then we have a few others as well, and then a bit of a mix in project management and project engineering, and also a few investors here on board. So the next question is, which industry do you work in? Okay, it seems like the space industry is winning so far. Anyone from other industries? A few medical, a few robotics, some other industries, undefined. Okay, it seems like, I think as expected, since this is the Jarvis Con Space Edition, most of us are space engineers. So really nice to see that, but also very nice to see that there are some people from the medical and robotics industry and some others. So that's really nice to know. It's nice to see that there is a diversity also. So now we're coming to some fun questions. So my question is, in which decade do you think that humans will land on Mars? Okay, some optimistic people here already in the 2020s. Okay, 2030s seems to be leading right now. It's a few years from now, but not too far away from in the future. Okay, someone who believes it's not going to be in this century. That's interesting. Okay, it seems like the 2030s, 2040s are winning right now. Let's see. Hopefully, we'll get someone to take us there in that time, or even in the 2020s. We'll see. Only time will tell. Okay, now another question. Where should we go first, do you think? Mars or back to the moon? Okay, we have a lot of moon supporters here in the audience. Few still believe Mars or think that we should go to Mars first. Okay, seems like the majority would like us to go to the moon first. Well, it's a bit closer, so let's see what happens. Okay, now on to some more serious questions, which have a bit to do with the talk also that we were going to hear today from Sam. In your company or your organization, which design methodology are you using, or are you not using any design methodology at all? Okay, it seems like most of the people don't use any, or maybe a custom one, a few agile, a few are not sure. One seems to be using waterfall methodology. A few others. Would be interesting to hear then in the end in the Q&As and discussion what other methodologies you guys are using as well. So it seems like, well, most of the people, well, now it's a tie between none and agile. I think that's interesting to see. Okay, let's move on to the next question then. Which words come to your mind when you think of efficient hardware design? What is efficient hardware design for you? Difficult question. Okay, keeping it simple, reusable, UX, cloud, okay, long lasting, mistakes, I guess that's the opposite of efficient, documentation up front, multidisciplinary, challenging, collaboration, versatile. Oh, that you have a lot of words that come to mind. Nice. Will go wrong anyway. I like that one. Not very optimistic. Low energy consumption. Prototyping, good communication, flexible. Pareto. Okay. I think we have a lot of ideas now, and I think maybe Sam will talk about some of these things in the talk. We'll see. But now we have an idea of what you guys are thinking, what efficient hardware design is for you. Okay, so before we start the talk, and before I present Sam, you have the opportunity in the end of the talk to ask Sam questions. And I will actually keep this slide open for you during the whole talk. So if you think of a question, you can actually ask it directly here in AHA Slides. So what you will be able to do is you will be able to write Sam a question here. And in the end, we're going to show this screen so that we can see what questions you guys have. You can also upvote questions. So if there's a question you think is really good and you think it should be asked, you can also do that. Another option is also, if you don't want to go to the AHA Slides, is also to either raise your hand in Zoom, and Maria will let you ask your question in person, or you can actually write to Maria, who is the co-host of this meeting, and she will ask your question for you. So without further ado, I'll introduce you. Yes, Maria?
Sorry, let me just interrupt for a second. Hi, everyone. This is Maria. I just heard from a participant that he is not hearing you very well. So in case someone has been having problems with the sound, just let me know, just to know if this is just a particular problem from one of the participants or if more people are experiencing this. Okay. Thanks, Luis. Sorry, go ahead.
Okay. No problem. Yeah, just let us know if you cannot hear well, and then we'll try to fix that. But hopefully most of you can hear us. Okay, so I would like to introduce you all to Sam Avery. We're very happy to have him with us here today. And Sam is a systems engineer, and he's currently working as a project manager for Momentus's Vigoride 2 orbital transfer vehicle. And this vehicle orbital transfer vehicle is planned to launch in February of next year, so it's pretty soon. So that's exciting. And additionally, Sam has also co-founded another company, which is called Odyssey. And that's a satellite communication startup where he led a 3U CubeSat demonstration mission. And today, Sam is going to talk to us about agility in complex spacecraft design, integration, and testing. So very welcome, Sam, and I will let you take the floor now.
Yeah, thank you. Thank you for the intro, Luis. So welcome, everyone. Thanks for attending. I will share my kind of unique slide deck that I've put together. So kind of to preface this, I decided to take a bit of a non-standard approach with this talk. And I've prepared my slides within Ballaspace's web-based tool. And the reason I did this is that I can develop kind of a living document, a living page within the tool that I can then update forever moving forward and share with my team, rather than just having, like a PowerPoint slide deck that just kind of disappears and we never see it again. So what I want to cover today is just briefly, what is Momentus? What do we do? I want to cover how we're organized in our projects and our teams. just generally how we cover quality assurance, our design, analysis, and test architecture. And then we have a couple of dashboards that we like to use to maintain alignment between engineering, business development, and just the Momentous team in general. So I'll show some examples of how we generate dashboards to make everyone aware of what we're doing. So for Momentous, we are essentially building connecting flights for satellites. So you can think of a rocket launches into a preliminary orbit, and that may be just kind of a standard low Earth orbit, say, where then Momentous's space vehicle would be deployed, and we have customer payloads that will be mounted on our spacecraft that we can then take to further orbits. So essentially, we can deploy a single satellite, say, at a first orbit, and then perform an orbital transfer to a new orbit and deploy another spacecraft. And then once we're done, we typically try to deorbit to not clutter low Earth orbit in space. So that's the general concept. So the problem we're trying to solve is one of the biggest hurdles when you're a kind of a space company and developing satellites is getting to where you need to go, getting to your final orbit. And essentially, you could buy a ride share on a rocket, like say a big rocket like a Falcon 9. You could buy a single slot in it and share the vehicle with many other satellites, which is cheap, but generally it would take you to some standard orbit, some maybe non-ideal orbit for your mission case. So, I mean, you could pay a premium and have the rocket take you specifically to where you want to go. But we think it makes more sense to essentially have a secondary stage or a connecting flight that will take you to kind of that custom orbit. And so that brings to the solution. We're developing essentially orbital transfer vehicles, or we call them kind of space vehicles as well, which have delta Vs up to 6 kilometers per second. And in the near term, it's more of like low Earth orbit and transferring satellites between, say, a standard low Earth orbit from a rideshare to some custom orbit. But looking forward, we would do things like transfers to the moon, to asteroids, and then even we're thinking to Mars eventually. And so the point is that we can do these custom orbits cheaper than it would be if you were to buy your entire custom rocket. And so just to give a little concept, our services, or I guess our products, we provide first Vigoride, which is essentially a low Earth orbit transfer vehicle up to 500 kilograms of capacity or payloads that we can support. And we can basically transfer throughout low Earth orbit. And then looking to the future, we have Ardoride and Fervoride, which are higher capacities. And these would be the vehicles going out to like geostationary orbit and the moon and so on. So in terms of project organization, we have a bit of a unique organization, I would say. We use what we call squadrons, to kind of take the term from Star Wars and random sci-fi movies. Essentially, these are meant to be loosely coupled, meaning that multiple teams don't have to interact constantly. They kind of are a small group that's very focused and knows what they're doing, but they're tightly aligned in a common goal with all the other squadrons. We base this approach off of Spotify's agile engineering culture. I have a link here. I won't open it now, but you can look up agile engineering at Spotify if you're interested. So we color code our squadrons just so that we can quickly identify who's working on what. There are a lot of colors sometimes, but it's cool to be able to quickly say like, oh yeah, that's blue. They're working on propellant. So that helps. So this is just meant to be. This is actually for Vigoride 2, the project I'm working on. You can see all the different squadrons we have, and I just have little call outs for which projects they're working on specifically, which kind of categories they work on. And just to describe this a bit, so squadrons are multidisciplinary teams, and they're meant to have specific projects so they keep focused, essentially have a defined purpose, and it's not the same as having, say, like a silo in a company where you have like a spacecraft department and a propulsion department. Instead, it's a tight group of people that has a specific project in mind. Each team or each squadron has a squadron lead, and that lead is meant to be both technical contributor, but also they're kind of like a mini project manager. So they support the project management for their small group, and we find that helps kind of, you know, reduce the burden of it kind of spreads out the burden of managing the project over a lot of people. And typically we'd co-locate for collaboration, but it's kind of difficult right now. So it's more just Zoom calls and keeping each squadron aligned. So generally we try to keep these to 4 to 5 people. Sometimes the scope's a little high, so we have more, but yeah, essentially it's meant to just be tightly grouped teams. I think I already covered these, but why we're doing this is because we want end-to-end life cycle development, meaning that when a team starts working on a project, they work on it from design to build to test to release, and so it's all kind of contained in that small team, and all the knowledge stays within the team. We also wanted to, as I mentioned, like bring awareness of costs, schedule, programmatics, and such down to the kind of basically to the engineering level, so that it's more of a distributed format. And as I mentioned, the biggest benefit for us is basically allowing us to be multidisciplinary, breaking down silos. So you can have a propulsion engineer working alongside a mechanical engineer, working alongside a software engineer, all in the same squadron. So maybe not the most interesting topic, but quality assurance. We do have a page to cover what we do for QA. So I'll pull this up really quick. I'm just going to briefly cover this. Essentially, we create pages within ValidSpace to cover our procedures, our policies, and how we do things as a company. And one of the first things that we try to put front and center is like a common design terminology, is how we communicate what we're doing to, like, within the team and to others. So I just wanted to show this briefly, that we have essentially a breakdown where I mentioned before, we have Vigoride, Arteride, Fervoride. Those are our kind of platforms, and those get broken down into missions. So Vigoride 1, 2, 3, etc. And we kind of split it by, it's essentially space segment and ground segment, like things we do in preparation for the vehicle and in operations of the vehicle, and the actual kind of hardware breakdown, which we have the flight system, which is everything. It's all of our customers. It's our own vehicle, and everything that the launch vehicle will take up into space. And we have payloads, which are our customers plus their deployers. So I won't go down into the breakdown more, but we do have kind of links so that everyone in the company can read into this and make sure that they're aligned. I think this is one of the key first things to do on a new project or program, is to make sure everyone's consistently speaking the same language. If not, then you just, things can run rampant, and everyone just is talking about different things. And to that note, we also have verification and compliance philosophy. So this is essentially another page that I won't open, but it just details, what does it mean when we say that we're going to do a test and analysis and inspection and so on. So we generally use NASA-based standards for that. Otherwise, this sheet shows, what do you do when you receive hardware? It's like a step-by-step guide. It shows, best practices, essentially, quality assurance for software, hardware, etc. And we detail like how you get part numbers and serial numbers and such, and procedures. But I will jump back to the main sheet. So yeah, essentially these are just links that, if somebody starts new on the project, the idea is that they can just jump to this presentation that I'm showing, and it'll help kind of bring them up to speed and see kind of what our policies are. So on to design, analysis, and test architecture. Now this is more of the interesting stuff, I think. Basically, we have a few key strategies we employ for assembly, integration, and test, or AIT. We try to design from the beginning of the mission with that AIT process in mind. And some things that we do is we develop a consistent design terminology, like I said, and we flow that through everything we do. So we have a product family tree. It's essentially meant to be the assembly flow. It shows you have your spacecraft, you have within that, within the flight system, you have the space vehicle, and within the space vehicle, you have the bus. And within the bus, you have this big branching tree of all the things that go into the spacecraft. So that's what this tree shows. It shows a kind of a logical diagram of how we represent things. And what that allows us to do is, with that kind of basis for a tree, we can then make a spacecraft model. So we create kind of essentially a database of our spacecraft in ValSpace. And that's essentially a tree, the same as the product family tree, mapping all these different pieces of the spacecraft to assemblies and assigning variables, documents, and so on to them. We have CAD models that also represent this flow, like in SolidWorks in our case. We have schedules. We use Rike for this, and it matches the assembly flow. And then, like I mentioned, part numbers, serial numbers, and hardware tracking. And then we also have, in our AIT planning and testing, we try to match this terminology and this design, this assembly flow. And this is an example of what that looks like. So this is the same kind of terminology I just showed: flight system, payload, space vehicle, etc. If I dig down on the space vehicle on the bus side, then we would have assemblies, which I'm calling out as ASM for short. And the assemblies are broken down. We try to keep it to no more than one further level, just to keep the high level overview of what the spacecraft is, manageable to keep in your head. But we have a series of assemblies, and these will be consistent and show throughout, our schedules in like a Gantt chart format. It'll show in ValSpace, like it's in our database. It'll show in this diagram itself, which I've generated in a software called Lucidchart. And generally, it helps keep us aligned, and when we integrate it, what is it, and what are we talking about in general. Also, by the way, this you might see throughout this presentation. This is actually a live diagram from Lucidchart. So if I make a change in Lucidchart, all I have to do is actually refresh this page, and then it will update this diagram. And I think that's been key as well to help keep us aligned. Essentially making sure our tools are synchronized as much as possible, so you don't make a change somewhere and nobody ever sees it. So here's an example of how this works. We have a product family tree. I just show a little section of it. So in this case, the bus breaks into what we call the communications panel assembly. And in there, I'm just pointing out that we have a star tracker, which is used to orient the vehicle relative to the position of stars in the sky. And so we map that to ValSpace, where we have that component tree. And it's the same tree. So it's bus, comms panel assembly, and then star tracker. And then there's essentially a bunch of variables and details about that star tracker. And since this is in ValSpace, it's all like a variable you can pull. So it's an API. You can pull the data from this, and then you can pipe it into your other tools as well. And so we track part numbers currently using Airtable, and so this will match. And then I just wanted to show in our Gantt chart and Rike, this is an example of the star tracker might arrive. We would do testing on it, and then we would essentially, once it's flight ready, then beyond this point, the schedule matches, it matches this flow. So the Star Tracker arrives, is flight ready, and then the next point in the schedule is the comms panel assembly, and then the next point in the schedule, after everything else gets integrated, is you have a completed bus. And so it just helps make it a little simpler to see what the actual timeline looks like. So now I wanted to briefly talk through what we do for simulation and analysis. So this is kind of the core of how we use Valospace and how we use our tools to try to do rapid design iteration. So this is another diagram. In this case, what this is showing is data sources, which is essentially all of our different stakeholders provide us information. We have a database, which is pretty much just we're storing all of our information, satellite details and whatnot in Valospace. And we write our own kind of external analyses and scripts typically. And then we have a series of outputs that we can provide to, say, regulators or to like another customer of ours or to a supplier and whatnot. So in terms of data sources, we have, say, the launch provider, SpaceX in our case. We have a series of customers. We have regulators and regulations. There's what I would call the space segment, which is the space environment. It's details of our vehicle and whatnot. And then we have requirements for the platform, so Vigoride as a whole. We have requirements for the mission, so Vigoride 2, for instance. And then we have essentially all the details behind the ground segment, which would be like the actual ground station and the dishes that we use to communicate with our spacecraft. All of this gets kind of fed in, currently mostly manual, but some things are being automated as we go, into Valospace as kind of our database. And this database, we split it into some categories. So we have what we call mission analysis cases, or MACs, MACs. And this is meant to be essentially a single page or storage area where you can have a design analysis case. So it could be, say, a communications analysis case where we're at altitude of 2,000 kilometers and we want to see how much data we can pass given a series of other variables. And so this sheet would show all of those inputs to the analysis in kind of a convenient format that we can pull. And then on the flight system model, this is basically just the product family tree I was showing. This breaks down into what we would call a master equipment list, which is pretty much like all the masses of the components, all the details of the components, part numbers, etc. And then we have payload sequencing, which is we define where our payloads sit on the vehicle and when they'll be deployed and what orbits they'll be deployed to. And in terms of regulatory documents, we have essentially we can create sheets every time there's some super annoying document that we have to fill out from range safety or the FCC or the ITU. We just create a page with variables in it, all the inputs that you need to fill out that document. And we're getting to the point where you have this list of variables and then you just run a script and it pipes it into a document that you submit to the regulator. So no more like sitting there filling out dumb Word documents and stuff. But basically we have all these parameters, all this data stored in a database. So then we write scripts typically. We write in Python a lot. We do a lot of stuff in Valospace too. We write like calculated outputs and have analysis pages like I'm showing here. But a lot of it is Python scripts that then output all the data we have stored into a whole bunch of formats. Like some cases it's just a PDF. PDF gets shot out and then you can send it to people. Sometimes it's Excel, plots, GIFs. So one example I'll show in just a bit is that link budget analysis that we have a bunch of variables for in the Mac. We run a script, it pulls the values, and then it produces some pretty plots of what our link margin is for that communications link. So the point of this, I guess, is and like how this ties into agility is this kind of simulation architecture or analysis architecture allows us to kind of create a feedback loop where whenever a data source is updated, whenever we get new information, we can update the database, so update ValSpace. And then we're starting to look into things like webhooks and whatnot to automatically trigger the scripting. And so the database gets updated, scripts triggered, and then it auto generates all these documents and things. Essentially, it's kind of a quick output of a huge amount of work that you would normally have to do manually. But now you kind of just get it all whenever you want at the click of a button is the goal. And so once you have these outputs, you get a clearer picture of where your design's at, and then you can more rapidly iterate your design and update your data. So the last things I wanted to show are essentially how we keep synchronized, how we make sure that we are moving forward rapidly, but we have kind of good communications paths between engineering, mission management, which is the interface to our launch vehicle, the interface to our customers, and business development, who's trying to sell the vehicle. So we created what we call a mission configuration dashboard, which is meant to be kind of our single internal source that shows what launch vehicle are we using, where is it going, and who are our customers. So the thinking is that you start this at the conceptual design stage. It could be copied from, Vigoride 1 copies to Vigoride 2, and so on. And then you refine it throughout your mission. So you kind of have a running baseline of what customers you have and what, I guess, configuration you have. And we include information about the launch, about the customers, and just general like high-level specifications and requirements. So I'll just quickly show what this looks like. And I apologize, I can't show anything that cool, unfortunately, due to, I guess, export controls and things like that. But I just want to give at least a feel of what it would look like and what we try to do. I swear I have actual cool dashboards that show a lot more than this. But yeah, basically it's the project title, couple of key people. We show essentially the layout of the deployers and payloads. In this case, I'm showing kind of an older version of Vigoride 2, bit of a boxy shape with a bunch of deployers on it. And essentially, what's missing here that I would normally have is we have kind of this lucid chart diagram, which keeps a running configuration of where customers are stored, and it can include information of when they're going to be deployed and whatnot. So it's kind of a quick snapshot of what the customer configuration looks like for us. And then we have a bunch of links to, like some of the outputs I mentioned, like the payload sequencing. It's an Excel sheet. Links to, where we store what we call containerized payloads, which is CubeSats in their deployers, and some other requirements and stuff. And then there's launch details. There's basically, like all the details of where the launch vehicle is going to drop us off at, when they're going to do it, and so on. And then we also try to show things like what orbits are we going to move between. And we actually have some cool like dashboards and plots that actually show, the transition between orbits, but this is kind of the quick text-based table version. So it's just meant to be a quick snapshot of, okay, we start at the launch vehicle injection orbit, and then we're going to do this maneuver up to, say, 600 kilometers, and we're going to transfer the local time of the descending node, or basically, shift the orbital plane a bit. So yeah, it's essentially just describing what that looks like. And then this is kind of a cool thing that we've started doing. We have mission specifications, which in this case, we try to show what's the current best estimate, what is the requirement or the maximum, and how much is remaining. So we show like for CubeSats, for instance, we would show let's say we're using 10U of CubeSats. We have that many CubeSats on our vehicle, and maybe we have 50U of CubeSats total that we can support. Then we have 40U of CubeSats remaining. That sort of thing. It just gives a quick snapshot of what the status is. And these are all linked variables, so it just updates as needed. And then this doesn't work because I just linked to random pieces of this like template essentially. But we would show a full mass breakdown in a pie chart, and then a full budget of the mass. So then, okay. So then the last thing I wanted to show is the design overview dashboard. So kind of similar to the philosophy that I started this with, the design overview dashboard is meant to be a living document as well. We kind of created this because we wanted to start something that we could keep iterating on. And whenever you get to, say, a critical design review or a future preliminary design review, or any sharing of information with other engineers, you have this just running document, which is essentially captures your design in its current state. So we made this document with the intent that you would start it right in the beginning. You would refine it throughout preliminary and detailed design, and you could present it essentially as your slide deck for preliminary design and critical design reviews. So I think I'm almost out of time, but I'll show just quickly what this looks like. So this is actually like a version of this with a whole bunch more info on it, is what I used for a critical design review presentation. So we first show kind of an overview. We show what our requirements are. We show this would be the actual full family tree, and we kind of expand it and show all the details. We show some CAD views, and then we kind of go into programmatics, showing the schedule, and we show budgets. So the master equipment list that I mentioned, we automatically output that to Excel, and this is just a link to that Excel. And then we show kind of the breakdown of the vehicle's mass, which is linked to our valve space database, so we don't need to go in and update this. Showing the bus mass time history, so we can see how things have changed over time. And then kind of so on. There's a bunch more other stuff. So I think this is kind of what I mentioned earlier. We have a link budget tool, link budget Python script, and it auto generates this kind of plot of what our link margin is at various altitudes. And this is one of the things that we're actually starting to link to valve space, so that you pull the data directly, output the plot. And this is the sort of thing that variants of this would be what we would send directly to, say, a regulator. So other than that, there's a bunch more. We include specifications that pull straight from our database, like what's our thrust, what's our propellant tank operating pressure, and so on. We include a whole bunch of requirements. We show kind of the constantly updated block diagram of the entire spacecraft. We link to kind of a diagram for the modes. So what do we do in a failure case and whatnot? And we have kind of the fault transition diagram to show that as well. And then there's a bunch more kind of design-based diagrams that we generally show and link. And otherwise, we show this whole section, which is what I was talking about, of taking like our mission analysis cases and then outputting them. We show essentially all the outputs from those cases. So we generate links to diagrams and links to those analysis outputs, and then show them all here. Sometimes it still is slides, but at least it's linked to a slide deck that gets updated. So yeah, that's about it for the design overview. I think if there's anything that's helped us kind of maintain agility, it's not wasting time. I mean, in the preparation of this presentation, I said to myself, like, we're really busy. We need to get things done. So I'm going to try to make something that I can reuse for my company. So that was kind of the intent of this, was that we can keep this dashboard, keep this analysis page here as a running tool we can keep using. So I think I'm out of time. Is that right, Louis?
Yeah, if you want to take a few more minutes, feel free. Otherwise, we can already jump to the next Q&A if you want.
Yeah, I think I'm good for Q&A.
Okay, thank you very much, Sam. It was a super interesting presentation. I think everyone is clapping on their muted their muted videos,
Yes.
but it was super interesting. So let's go to the Q&A sections. Can I take over the screen share from you, I guess? So I can see that we already have a few questions. If you want to ask a question, anyone participating in the audience, please feel free to go to, again, this link, houselights.com/Jarvis, or write directly in the chat to Maria and she will relay the question. Maybe before we jump into these questions that we already have, I have one question for you first. And it's about, you talk a lot about automation and scripting and this rapid feedback process. And it seems like a very modern way of working, probably something that a lot of companies haven't reached yet. So if there is someone in the audience, for example, that is thinking about going to this approach, what would you say is like the first step that they could take to go into a more agile way of working?
Yeah, I guess, I mean, I think the key is to have a common database, really. If you want to automate things, you need a single source of truth, is the term that we commonly throw around. If you just have a bunch of, Excel sheets and you have Word docs and things like that just floating all around, it becomes so much harder to make sure everyone's consistent and actually knows what you're building. So having one kind of consistent place everyone can go really helps. In terms of just being agile too, making sure that, like, I think that key point I brought up about how you need your design terminology and your communications consistent. I think that's one of the key things to think through, is to essentially define what terminology you're going to use, so people aren't talking over each other saying, different things all the time.
Yeah, that's a great start, I think. Okay, let's jump to the questions we see on the screen. I think there are a few upvoted questions, so maybe we start with the most voted one. How do you deal with requirements updates after the design phase?
Yeah, so we have requirements. We keep those in valid space, and essentially, if it's a platform level requirement, so something that is essentially interfacing with the business and has inputs from sales and mission management and everyone, then we follow a change control process. So that's a little more rigorous of a process. We have to bring in some people and everyone has to approve. But if it's essentially a systems level requirement, changing some detail of the design of the spacecraft bus, we generally we use a process where essentially the project manager and the technical lead both kind of approve the change, and then it can move forward.
Okay, nice. So another question from the participants: can people be in multiple squadrons? I guess they mean, like, if you have one mechanical engineer, how do you divide that between the different squadrons?
Yeah, I guess I would say the goal is to not do that, because then you can give people an individual, like, sole focus. It's a good practice in general to I guess single task rather than multitask, but in reality it does happen, and so we do have people in multiple squadrons as needed. and it's fluid in a way. Like if you're missing some resource, you pull in somebody, to help you on that single thing for, a week or a day or whatnot.
Mm-hmm. Yeah, because I guess if you said that there were four or five people in each squadron, right?
Yeah.
So I guess sometimes it's difficult to keep all of the skills necessary for that project in just those few people, right?
Yeah, that's true. It's sometimes we bring in consultants. Sometimes we bring in contractors as needed, or internal engineers will kind of shift between squadrons as needed to help with design. But yeah, it's mostly meant to be kind of a way to start structured and to maintain structure so that we can be aligned.
Yeah, that makes sense. Okay, so we have a few more questions. So you talked a lot about the Python scripts. So are these Python scripts written by everyone, or are there dedicated people that have these skills to be able to write those automated scripts?
It's not really by everyone, but we probably have like five or more people that write those scripts, and a few of us that kind of are working down this automation route. So yeah, there's people in, say, the mission analysis squadron and mission analysis group that write Python scripts which pull data from ballast space and produce kind of pretty plots of what the orbital trajectories look like. And then I was the one that wrote the Python script for the link budget, why I kept mentioning it. And then we have a couple others that write the Python scripts to, say, pull the data and pipe it into some regulatory document and other things.
So would you say that for all the students that are joining us today, Python is a skill that they should look into?
I think it's a good skill. Yeah, absolutely.
So next question is, what is the size of the satellites that you transport?
So the vehicle that I'm working on, Bigger Ride 2, is a little over, it's like a meter, 1.2 meters by 1.2 meters roughly. So it's pretty large. It's like a large coffee table kind of thing. So that's kind of the footprint. It's like a 2D 1 meter by 1 meter plane that satellites can sit on top of. And generally in the first few missions, we're mostly transporting CubeSats, which are like, it's like the size of like a 2-liter bottle of something. It's like a 3-unit CubeSat is like a 2-liter bottle of soda or something like that. So we transport a ton of those CubeSats, like up to, I think we'll be transporting up to 24 of those on the first mission. So yeah, it varies.
Wow, that's nice. So next question is, well, this is changing depending on how people vote, but next question is, how do you guys automate the CAD file generation and updating? Do you use Valley Space for that in any way?
That's something that I really want to do, but I think it's pretty tricky. We use CAD, we use SolidWorks for CAD, and we use a PDM tool they have, which allows us to essentially store and check out all of our CAD files. And so the best we have now is that we kind of link between ValidSpace and that CAD, but we don't yet have the ability to auto-generate the CAD and display it and, like pull data from ValidSpace and port that into SolidWorks. It's something I want to do though.
Yeah, that's a good future feature.
Yeah.
So coming to the next question. So this approach looks great for early conceptual and preliminary design phases, but is it not a challenge to implement for detailed design?
Yeah, so I kind of briefly showed it, but like essentially that, at least like the design overview dashboard, for instance, it's just meant to be like the high level quick snapshot. And then you may have noticed there were a bunch of links to other things. And so those delve into like extreme detail. It's like a normal critical design review where you have, like very detailed breakdown of all the design pieces and hardware and CAD models and description of risks and everything else. So it's kind of meant to be, we have a quick, easy landing page, and then from there you can dive into the details.
But does your approach kind of change from when you go from the preliminary design phase to a more detailed design phase, or do you try to use the same iterative approach in the detailed design as well?
I guess I would say this is our first time doing it, so we'll learn. But yeah, the intent is that most of what I showed, we would follow essentially that same process from start to finish. And so the intent is that everything we're doing, you don't throw away what you've been working on, you keep iterating on it. So we adjust the product family tree if we learn that we need to. And then we, by the time we hit detailed design phase, that product family tree is much more solid than it was at preliminary design. And everything else flows from there.
Yeah. Nice. So another question
Please.
we have? Yeah.
We received also a few questions here on the chat.
Yes.
Maybe I can read one or two.
Yes. Sure, go ahead.
All right. So first we have a question from Carlos, and he wants to know, how do you manage value space permissions within the same squadron and across squadrons?
Oh yeah. So we currently give all squadron leaders that are related to a given project or to my mission, for instance, we give them access to write to ValSpace. Everyone else is pretty much read. So essentially there's just this few key people that are given permission to write. And in some cases, for instance, with mission managers, we actually only give them permission to write to certain aspects of the customers. So it's a bit of case by case, but for squadron leaders, we generally give them full access.
Great, thanks for clarifying. So another question from Simon. How do you train new employees in understanding and working with your design methodology and management tools?
Yeah, so the sheets that I showed are a start. So basically I can just pass those to new people. There's also, essentially whenever we have a meeting to train people, we try to record a video. And so that way, we're not repeatedly doing the same training over and over. So generally it's you go to these pages and there's a bunch more links I didn't show, but you can keep going down the train to see all the different details of what we do. And we're working down kind of a roll-up dashboard of this stuff too, so that you can find everything you need to know about our engineering policy from a single page.
Great, thanks.
So I think we have time for hopefully a few more questions of these. We're ending soon the session, but how much of the actual spacecraft manufacturing do you automate? Is it mostly innovation in organizing?
Yeah, it's more so on the organization, definitely. But in terms of automating the manufacturing, once we're able to synchronize between our physical hardware design, so CAD with the spacecraft database, the model, that will help. Then we can essentially auto-generate the CAD and perhaps even do things like companies like Xometry and Proto Labs, you can get an instant quote from them. So I could see a future where we, I guess you make a change to the design, the database, and then it runs the scripts, it connects to CAD updates, it sends something to Xometry and Proto Labs, and you get a quote for how much the spacecraft is going to cost you. Maybe something like that we could do, in a month. No, I'm just kidding.
Yeah, I think
sometime soon.
I think that would be very cool. It sounds like the right way of the future of engineering to be able to do that. So I'll just take, we'll see if we have time of all the questions, but how do you plan your verification to make sure that the spacecraft works before launching it?
Yeah, so We use verification and compliance. We basically define a whole requirements tree in ValSpace. And then that's essentially, you know, what is the platform level requirements? What is the mission level requirements? And then the system level requirements is, you know, is this thing actually going to work? So we have a tree of system requirements, and we define basically verifications at multiple stages throughout the project for each requirement. So if there's a requirement that say like we need to avoid a death mode of the spacecraft, which means that you issue a command and it kills the spacecraft. That requirement then has, say, an analysis, a test, and maybe an inspection or review or something. And those will be throughout the process. So maybe at critical design review, we have a review stage. We have a test that we do at, say, during the assembly integration and test process. So that's generally how we do it.
Nice, thanks. So maybe we'll go a bit over time, but I think we can manage all the questions that people had. So what is the biggest advantage, change, difference when you start using ValSpace individually or as a company?
Yeah, so we were doing, so for instance, we had a master equipment list before we started ValSpace. And that showed, you know, all the components of the spacecraft is very detailed, a very detailed Excel sheet. But the problem was that we would end up with like a few different master equipment lists, and they would be in different folders, and some people would download them directly to their computer and whatnot. So the best advantage in terms of, you know, having a single source of truth is that, you know, ValSpace became the database, that single source that everyone could go to. And now they no longer need to, you know, have some random month-old master equipment list. You just click on ValSpace and there's the true mass budget. So yeah, we use it for the source of truth.
Cool, thanks. So what does your vision of a fully integrated process look like 5 years from now?
I guess I've kind of alluded to this, but yeah, I mean, basically it would be that schema where you, as much as possible, all the inputs are automated. Really, I think it kind of boils down to you have a series of inputs to your design and then your output from your design, I guess. And so, and they kind of, you know, mingle together. You can create a feedback loop between what your design status is and how you feed into the design inputs. So I would see some type of automation of, we get inputs from the launch provider, we get inputs from, I guess, our requirements, we get inputs from customers. And as that gets fed in, we pull that data directly, and we have a design flow where the data goes into ValSpace. ValSpace pipes to our scripts or whatever we run, integrates with CAD, for instance, and the CAD model maybe updates on its own, which would be amazing. And maybe we template our software. So there's a lot of options, but essentially I could see a format where you essentially script all the processes so that pretty much what's left is the kind of the qualitative levels of the design, if you will. And then essentially you get kind of all the feedback and data you need in real time.
Yeah, really interesting. And I think it goes into the last question that we have also, which is, from all of these things, what is the next big goal in terms of automation that you want to take now for at Momentous for the company?
That's a good question. I think the next, I mean, maybe it's not a big goal or step, but the next thing that I really want to do is, like I mentioned, we're starting to do automation using things like webhooks, but we don't really have that fully set yet. So I do want to make it so that, you know, I think we have like 6 or 7 scripts or something now, maybe even more. I want to make it so that we make a change to ValSpace, it automatically runs everything that we have, and then conveniently outputs that format.
Nice. And with that, thank you so much, Sam, for joining us today. It was a really interesting talk, and I think that the participants enjoyed speaking with you and asking their questions. And I would like to thank also all the participants for joining. We have another talk next week, Thursday. So if you want to join us, there's going to be Giada Stanisia joining us from OHB Sweden. So please feel free to go to our website and sign up for that talk. And I hope to see you next week. Thank you all so much.
Yeah, thanks everyone. And thank you, Louise.